Alright, operations with scientific notation is like one of my least favorite things. Because I am allowed to have least favorite things in math, right? I can be honest with you. So, we're going to do these. See how this goes. Maybe do some homework together on this lesson because, I don't know, I think they're difficult. Maybe they're not really to you, but some of you might think they are. Pluto was demoted from a planet to a dwarf planet in 2006, which most of you don't even remember because you were like 1. I remember, though, I was a freshman or sophomore in college, so I was already, well into my life, in part because of its small size. The mass of Pluto is about 1.3 times 10 to the 22nd kilogram. About how many times smaller is Pluto's mass than Earth's mass? The mass of the Earth is about 6.0 times 10 to the 24th. Good thing they told us that because I could not have told you that. So we're going to write the ratio of the mass of the Earth to the mass of Pluto. Oops, I need my marker. I wish I could change the color. I'm getting sick of red and blue. So, write the ratio of the mass of the Earth to the mass of Pluto because we want to know how many times bigger Earth is than Pluto, which means we need to divide Earth by Pluto. So it tells us that Earth is 6.0 times 10 to the 24th, and it tells us that Pluto is 1.3 times 10 to the 22nd. Okay? So, split the problem into 2 parts. Divide the coefficients and divide their powers. So, what they mean is they mean put your first numbers as a fraction, so 6.0 over 1.3, and then put your powers of 10 as a second fraction times 10 to the 24th. And divide the powers. Remember, when we divide the powers, we subtract the exponents. We take our numerator minus our denominator. So that's where they got the 24 minus 22. At the same time, they divided the coefficients as well. So they took 6.0 divided by 1.3 and got 4.6. So we have 4.6 times 10 to the second. So Pluto's mass is about 4.6 times 10 to the second. Now that I taught that this time, it didn't seem as difficult. Maybe it's because I made it way too confusing when I used to teach it, which doesn't surprise me. Sometimes I do that. The mass of Venus is about 66 times the mass of the moon. What is the mass of the moon? The mass of Venus is about 4.87 times 10 to the 24th. So because we want to know the mass of the moon, we have to divide the mass of Venus by the mass of the moon. Okay? So we are looking for the mass of the moon. We don't know what the mass of the moon is, so that's why they put that there. We do know that the mass of Venus is 4.87 times 10 to the 27th. Or 24th, I'm sorry. And if we were to take that mass and divide it by the moon's mass, we would get 66. So we're going to write 66 in scientific notation. First we're going to bring down the 4.87 times 10 to the 24th. And remember to write 66 in scientific notation. You move the decimal in between the first 2 numbers and you get 6.6. So we have 6.6 times 10, and we move the decimal place 1 place left, and it's positive because our starting number was greater than 1, so our exponent is positive. So now we can solve for the mass of the moon. And how we do that is we take 4.87 times 10 to the 24th, and we divide it by 6.6 times 10 to the first. Okay, we just switch places. We're going to divide the decimals and subtract the powers, just like we did in example 1. So we're going to take 4.87 divided by 6.6, and we're going to get 0.74 times 10, and then we're going to take 24 minus 1 and get 23. Okay, now that isn't in scientific notation because your decimal isn't a number between 1 and 10. It's a number smaller than 1. And when we write in scientific notation, we want our number that's timesing the 10 to be between 1 and 10. So we're going to move the decimal 1 place in between the first 2 numbers. So it's 7.4. And because we moved it to the right one place, that would be 7.4 times 10 to the negative 1. Okay, because that number was less than 1, so our exponent's negative. So we bring down our 7.4, and because it's a negative 1, we subtract 1 from the 23 and get 22. So the mass of the moon is about 7.4 times 10 to the 22nd. The water in Mono Lake, California was used for residents of Los Angeles. As a result, the lake's volume in acre-feet dropped from 4.3 times 10 to the 7th to 2.1 times 10 to the 7th from 1941 to 1982. After becoming protected, the lake increased in volume by 5.0 times 10 to the 6 acre-feet in the next 20 years. How much did the volume decrease from 1941 to 1982? We are going to write the subtraction problem. We're going to put 1941's volume first because it's more, and then we're going to subtract the 1982 because it's the smaller number. So we have 4.3 times 10 to the 7th, and then we have 2.1 times 10 to the 7th. Okay? So we're going to write a subtraction problem. Boom. So 4.3 minus 2.1 is 2.2 times 10 to the 7th. Okay, this part doesn't change. So 2.2 times 10 to the 7th. Because they're the same, they don't change. All we do is we subtract the decimals. Right? What was the lake's volume in 2002? Now this was the lake's volume in 1982, and then it went protect mode. So we're going to add how much it gained. So we have 2.2 times 10 to the 7th plus it increased by 5.0 times 10 to the 6th. Okay? So because our powers are different, we need to rewrite them so they are the same. Okay, and in order to do that, we want to be able to add 1 to the 6. So I'm going to rewrite 5.0 as 0.5, and when I do that, that changes it times 10 to the 1st. And because it changes it to 10 times the 1st, there's a positive 1 on my exponent, so I can make that 6 a 7 now. Okay, so now instead of having 2.2 plus 5, I have 2.2 plus 0.5, which is 2.6 times 10 to the 7th. So we might do our story problems together because those can get a little confusing. A country has a population of 2.2 times 10 to the 7th people and a land area of 9.2 times 10 to the 4 square miles. What is the population density of the country expressed as people per square mile? That goes with number 1. Around the world, there are 1.2 times 10 ninth people who speak Chinese and 6.6 times 10 to the 7th people who speak Korean. How many people speak Chinese or Korean around the world? That is a total that goes with example 3. And you are going to have to find common exponents. Okay? And then in 2009, the Asian population of Asia was 1.17 times 10 to the 2nd times greater than the population of Oceania. If the population of Oceania was 3.5 times 10 to the 7th, what was the population of Asia? That goes with 2. So this is example 1, example 3, and example 2. Try it with a friend, try it on your own, whatever you prefer. Try those. See what you get. This stuff is not easy, and unless you're like a really awesome scientist, chances are you're not going to really use it. However, you do need to know how to do it for your test, and just, because that's what I say. So we'll do some of these in class together, and try and do those, check it out on your own, and then try and do some on a, pick a, what am I looking for? Assignment to do. And then maybe all do the same assignment and we can work on a lot of those in class together, as long as you're good and paying attention.